Hi, my name is Glenn Weinreb, and today we're going to look at how a next generation building automation system could potentially reduce carbon dioxide emissions, reduce cost, and increase comfort. For example, more automation could allow us to control the temperature of each room and help move heat from one room to another. To fully automate buildings, we would need to place a microprocessor chip in every device and connect them together with reliable communication. Devices include things like light switches, light sockets, HVAC equipment, window thermal covers, appliances, motorized dampers in ducts, fans in ducts, occupancy sensors, temperature sensors, and fire detectors. To facilitate global acceptance and ensure bug-free operation, the same free and open operating system software would probably be needed on all devices. This is easy to do since free software, such as this, is readily available. An example is Building Bus, which was developed by my nonprofit organization several years ago. When one flips a physical wall light switch, the communication between the switch and the ceiling bulb works correctly more than 99.999% of the time. This is commonly referred to as 5 nines reliability, and it is important since occupants will not tolerate less reliability. Unfortunately, wireless and power line communications do not provide the needed 5 nines. Therefore, a communications data wire probably needs to be added to power cables embedded in walls. And this could be done at the time of original construction at close to no additional cost. To reduce costs, devices could be divided into 2 categories, light and heavy. Light might consume less than 20 watts and include bulbs, switches, sensors, and small motors, while heavy supports 110 or 220 volt AC outlets, HVAC equipment, and appliances. From a cabling perspective, light might be supported by 48 volts DC power and 1 communications data wire, while heavy is supported by 110 or 220 volts AC power and 2 data wires. Most devices in a building are light and could save money with multiple techniques. These include smaller cables, less conduit, fewer safety requirements, and less expensive electronics. To support plug-and-play operation, standards would be needed that define how devices connect electrically, mechanically, and with data communications. Before standards are proposed, devices would need to be designed, prototyped, tested, debugged, and improved. And this might cost tens of millions of dollars. So who might fund this, and how might it be structured to meet the satisfaction of the various participants? Well, nations resist being controlled by external entities and therefore might require new standards be based on free and open technology. Companies cannot afford to give their money to their competitors, and governments rarely provide technical leadership. Therefore, a foundation or high net worth individual looking to save the planet from climate change might be needed. The Gates Foundation is uniquely suited since Bill Gates has experience developing operating systems, devices, and standards. For details on how to develop a next generation building automation system, click on the link in the description below. And for more Climate Lab videos, visit www.aplantosavetheplanet.org. Okay, that's it for me, and I'll talk to y'all real soon.